Hi, my name is Frederico Hakamini, and I'm Principal Curriculum Developer here at Okta. Welcome to Secure Your Modern App with API Access Management, a session that I delivered in Octane 17. This session is for experienced developers. In this session, we will learn how to protect your REST API using API Access Management in OAuth 2.0. So if you are developing a modern application such as progressive web app, a mobile app, or a single-page application, or even a microservice, this is a can't-miss lab. So let's get started. So these are the objectives for this presentation. We will start by briefly defining what's a modern application, and we will do this just to frame the conversation around what are the security challenges typically found on this kind of app. Second, we will launch a modern application, discover and exploit a vulnerability on its backend API. Third, it's where everything gets interesting, right? We will protect our application using Okta API Access Management. And finally, you will understand how your application can actually leverage the API security that's provided by Okta. So let's start. So if you are on the tech industry for a while, you notice that the way we develop apps changed a lot in the past years. If you were developing an app in the past, most probably the only option you would use for developing your app would be a monolithic application or monolithic design. In the monolithic design, you would have an app that would have everything inside that same process. So you would have the UI and also all the business logic. The only thing that might be outside this app would be the data storage, right? The database where you hold the data. So you would have a single URL, let's say localhost colon 8080 or a different website, and your public or premium customer here on this example would hit this process or this application, and this application would inside itself process everything, process and present a UI, compile a UI, receive requests, process the request and all the business logic, and answer with data. So with the advent of new interfaces, public cloud services like Okta, and the way we consume services through REST APIs, the applications started actually to change. The first noticeable difference is that the applications started to be segregated to innovate faster. So instead of having this monolithic application with everything bundled inside, we started actually to break the application in different parts. So in this slide over here, you can see two apps, right? You see this front-end application where public and premium customers are hitting this, and a second app over here which is just holding the business logic, in our case, to deliver premium and public promos for these two users. So why segregating, right? Because customers are using different UIs. So it might be a web application, it might be a mobile device, in a mobile app, in iOS or Android. And you want to innovate faster, so you can build different UIs and still consume the same business logic that's over here. The second thing that you can see is that to make this happen, right, to make this democratic and available for all UIs, we started using reusable APIs. So all this business logic for, in my example here, returning premium promos or public promos for our customers, they are consumable. All this logic is consumable through different UIs. And the third thing is that because these UIs might be in different programming languages, sometimes you're using Angular, you're using Swift from iOS, or you're using Java or Kotlin for Android, you want to use something that's democratic and available for everybody. So we started using HTTP communication on the internet. So if you have a user using a mobile app, this user doesn't need to be in an intranet or within a security perimeter, right? This UI can actually hit the API anywhere from the internet. So this new way of developing apps actually brought out a lot of agility and innovation and better customer experience. However, it started introducing some security challenges, and we will start talking about these challenges later. So I know this is a very brief explanation of what's a modern application. So if you want to learn more, I highly recommend you to visit the 12factor.net. It's a great website that explains what's a modern application. You can see a link in the bottom right corner of this slide. Just to give you a more concrete example of what's a modern application, I just put here some cool trends and examples you can see on the internet today, or that some developers are using, right? They are all, although they might be disconnected here, they all use that same concept we explained in the previous slide. Segregating components, exposing APIs for everybody using REST or HTTP based interfaces. In the microservices architecture, we basically use more aggressively the segregation, as you can see here on my diagram, right? So you segregate components, and this brings you flexibility. So you can swap components, you can create different versions of them, and all that. With serverless, this is a new concept, and you can see in places like Amazon Lambda or Google Cloud Functions. Because you are separating processes, you can actually drop your code in some places, like I said, Google or Amazon, and they take care of servers and everything. So you don't need to care as much about the infrastructure and the underlying complexities of that. You just expose your cloud function through a REST interface or HTTP, and you're good to go. Within the third bucket here, we have progressive web apps and single-page applications. So if you already worked with Angular, React, Ionic, or Vue.js, you know there are new ways of creating web apps that work both offline and online. When they are offline, they basically create a cache of all the changes you're doing over there. When they come online, they just sync up with the backend server. With natural language processing and chatbots like Hubot, API AI, and Slack, you can actually expose a different kind of UI. So instead of having just browsers or mobile application, you start having chat. So you can type in Slack, hey, do this for me, and actually this connects to a backend REST API that will do the service for you. Or you can say, okay, Google, give me information about this, or do that for me, Alexa, and it will trigger the same REST APIs. Within the mobile bucket, you can see, for example, Swift or Meteor.js, Ionic, Java, Xamarin. So all these are technologies you can use to build front-end UIs that would connect to that modern backend APIs, so you can actually consume this through a mobile device. And within vendor neutral, you can see services such as Okta, Google Cloud Platform, Amazon AWS, and MuleSoft. So what these services will do for you is that they will provide the backend APIs you need for delivering a great UI experience, a great solution for your users without having to build everything that sits in the backend part of the deal, right? Great example of this, I can point you to maybe 2 or 3 that I like a lot. For example, you can use Stripes for payment, so you don't need to process credit card information and all that. You can use APIs for that. You can use Twilio for notification, and of course you can use Okta for delivering the API security and the authentication that you need for your users. These are just few examples, and there are a lot of things coming up, such as artificial intelligence, physical and digital blur, non-visual UIs. There are several trends, but the good news is that all those trends, they use that same kind of app architecture, the modern app architecture we explained in the past slides. So they segregate components, expose the backend through REST APIs, and the UI can consume those through HTTP protocol on the internet. If you already watched Chris' presentation about single sign-on with OpenID Connect, you could see that we already provided single sign-on to a modern application. If you didn't watch this before, I highly recommend you to do so. In his lab, we basically use that same design over here to deliver Octa-ICE promos. This is a simple application we have that has this front end built using Vue.js, which taps into a REST API to return public promos for this customer and premium promos for this one. So for doing single sign-on in this app, we used OpenID Connect with JSON Web Tokens. So in this session, which is a continuation for single sign-on, we will actually explore that Octa-ICE loyalty program, that solution, and we will try to get promo codes that are supposedly available only for premium customers. So let's start. As you can see over here, I'm already in my desktop and I have my browser opened. I'm already logged in my Octa org, right? I'm using the Octane 170707. This is the name of my org. You might have a different one for you, right? Each one has an individual. And within my org, because we are continuing with the single sign-on with OpenID Connect, we are past that lab. I can go here in under application. I'll see the promos UI. This is already pre-registered for me, and if I open to check the details, you can see that I can check not only the kind of OAuth flow I'm using here, which is the implicit flow for authentication and single sign-on, and I have my application hosted on localhost colon 8080. Okay. With this page, I'm just gonna copy the client ID and I'll go to my application that's already open in Atom to make sure everything is fine. So let me open the application, and inside my app, I want to just edit my authentication code to make sure I'm using the proper client ID here, and also the proper Octa org, which I said in my case will be 170707. Okay, so after I save this, I control saved what's in here, I will launch my applications. To do this, I launch a terminal, and I'll start by launching my resource server, PIAM ICE-resource server. And now that I'm in this folder, I'll do npm start. So the resource server, just so you know, is the API I'm trying to call and talk to. Okay, so here in this lab we're working on is the API that's gonna return public promos or private promos, premium promos for our customers, and it's hosted on localhost colon 5000. So if I do here public promos, you should see some promos here in REST, right? So you can see 10 Office, Willy Vanilli, and we have some cool promos for people that want to buy our ice cream here in our example, the Octa-ICE. Okay, now that I have my API running, I'm just going to start a new terminal, and in this second terminal, I'm going to run the interface, right? The UI that sits on up front. So let's go Octane 17 and API AM ISPA app and npm start. So this application here, the UI, it's developed using Vue.js, as you could see from the slides I showed you before. But really, you can go with any front-end UI framework of your preference. So if you like Angular, if you like React, you can go with each one of these. So I used to have a token here from the previous session that's no longer valid because of expiration, so I just click to ignore that. And you know what? Let's try and log in. So to log in, I'll click my profile over here, and I'll do my login as john.smith at octaice.com, and my password, I'll put it over here. And what this is doing over here is an authentication to Okta using OpenID Connect, right? Because of this, I can get token information from Okta. You can see that the login is provided by my own Okta org. And within this login, because of that, I can access actually premium promos here. When I make this premium promo call, what's actually happening is that my application over here is making a REST API call to that localhost column 5000. Okay, so if I try and log out over here, I want to show you something, that this front end is actually protected, right? So if I try any premium promos here, I cannot do this unless I log into my application using my Okta credentials. So same thing with my profile. The only one I can actually get promos is I can use actually is the homepage and get public promos. Okay, so let me go back and log in again. John Smith at octaice.com, and only after that I can again go premium promos and make this call. Okay, so alright, it's pretty straightforward, right? I have this UI and I need to be logged in order to access the promos. But remember, this is a modern application. And a modern application means that my UI is making the REST API calls straight from my app without being being actually insulated, let's say in a intranet or within a process in a monolithic application. So let me show you how this call is made, and actually how hackers, in malintentioned people actually can take advantage of your API calls. So what I did over here first, I clicked here the three dots and I went to more to, and I launched here, actually from here I launched the Google Chrome developer tools. Okay, I'm using this just to quick snip into the network and show you what call is made to the REST API in the backend. See this. Every time I click premium promos, actually there's a call that goes to localhost column 5000 /promos/premium. Okay, this call is available on the internet, and because I'm using Vue.js, it's making the calls from the customer browser, in my case Chrome, Google Chrome. If you were using iOS, Swift with iOS, a mobile app, the mobile app itself would make those same calls if you're using Angular, if you're using React, as I said, and so on and so forth. What I'm doing here, I'm basically copying this call. Okay, let's show you this. So I'm already logged out, so I'm not supposed to get premium promos, as you can see. But if I launch a new tab and I paste that information, that same call, you can see that I actually have access to this. So you see the premium promos, those same ones I saw there in the table, I have access to them just by circumventing the UI that's protected with login. And if I want, right, I can use these codes and have access to better promos without actually having an account, which means I'm basically exploring a vulnerability in the promos application. So this is not something good, and actually this leads to a fact: we need to protect our REST APIs in order to have a bulletproof solution. So going back to our presentation, we basically exploit vulnerability in our promos API. And to do that, we just use the very basic workflow, right? We just launched Google Chrome developer tools, and we started tapping into the network to see what API calls our front end were doing, and we try to execute that same call directly outside the app. seems like a very simple kind of attack, right? But actually, there are a lot of ways of reproduce the same thing. So if you have a mobile application, as I said, you could have during the demo, right? A way you can tap into the network and monitor traffic is through some router that might be in between the application, oh sorry, the mobile device and the internet, if someone is accessing the Wi-Fi, or by just monitoring what's happening within the operating system of your mobile device. So it's fairly easy to gain access to the network activity of your application and try and see what are the the REST API calls this application is making throughout the internet. And for sure, when you explore, you actually have access to confidential information you're not supposed to have. And in our example, a malicious coder, someone with access to those REST APIs, they can actually access the promo codes from premium promos that they are not supposed to have access to. These kind of API attacks are getting so popular that they are making the OWASP top 10 this year. So the final OWASP doc is still in progress, right, in the works, but you can already see the API protection in the drafts, and it's actually a top 10. So it's been a very popular kind of attack, and you got to prepare and protect for that accordingly in case you're using a mobile application design where your UI and where your business layer are separated. And now that we know how APIs are targeted from authorization and access standpoint, let's change our mission, right? Now, instead of exploring, we will try and defend the same APIs we saw over there with Okta ICE promos. And to use this, we're gonna work with OAuth 2.0 and Okta API Access Management. OAuth 2.0 is a modern standard for securing access to APIs, and Okta API Access Management is basically Okta's OAuth as a services solution. It extends your Okta tenants with the ability to act as an OAuth authorization server and issue OAuth 2.0 tokens that can be used to access protected APIs. So in interest of time, we're not exploring the OAuth details here in this presentation, but if you want to learn more about it, I highly recommend you to either visit www.oauth.com or sign up for our new OIDC in OAuth course for developers. These are the main steps on our labs starting now. So we will start first by defining our own OAuth authorization server in Okta with its own custom scopes and access policies. API AM is the product that will provide us all that capabilities. Second, we will update our promos API code, and the code will be able actually to check the access token and scope within a request. So the scenario is simple. Someone, right, either an application or somebody will make a REST API to that premium promos call. And because we will be working with OAuth, we will expect an access token to be provided with the request. This access token will be checked out to make sure it's valid and it's not tampered with. And only if the user has the access token with the proper authorization, we will actually process the request and answer with the premium promos. In the third step, what we will do, we will basically update that UI we have, the front end, to request the access tokens to Okta with the proper scopes and send the tokens in API requests. Finally, on the last step, we're gonna check the results and you will see how the API protection works in action. So this is the best way of understanding how all those things like scope, access token, Okta API Access Management, and OAuth are correlated. What about we start, right? Let's go and configure the API AM. We're gonna configure register actually an OAuth authorization server within Okta, we will add custom scopes. In these scopes, they work like authorization grants that we will use, and we're gonna register an access policy with rules so applications can actually get tokens and make REST API calls using Okta. So here I am back to my Okta org, and to configure the API IAM, I'll go to Security API right over here. And to register one new authorization server for me, I'll click it over here, Add Authorization Server, and then I'll start adding information about my authorization server. So let me do Promos API as the name. Audience, I will enter localhost colon 5000. Just so you know, the audience, it meets, it it has to be, I mean, it's recommended that it is the same URL as the API you're trying to protect. In my case, because my APIs are under localhost colon 5000, that's what I'm using over here. In the description is just for, you know, to make it easier for you to manage in the future. So here I'm saying it protects my REST APIs for Okta ICE promos. Let me just do here, promos. Okay. Now that I created that, I'll just save some information from here, actually the issuer. The issuer, to make it simple, is basically the address of this authorization server. So every time my API, my UI needs to get a token to access the Promos REST API, it will go to this address. And every time my Promos REST API needs to validate a token, it will use the information from this address, this issuer, to make the token validation and to check whether it's tampered with or not. So let me just save this real quick so we can continue. So now that I have my authorization server to issue OAuth tokens, I need to add a scope, a custom scope. In OAuth, an OAuth scope is what links the request to an authorization. So check it out, the names I'm deciding to put on these scopes, and I hope you can correlate to my APIs. So the first one I decided to create is promos create. The description will be scope can create new promos. The third one, promos delete. So you see that I created custom scopes, and with each of these scopes you have different authorization rights. So for example, if you have the scope promos read, you can read the premium promos when you make a REST API for that. Okay? You see later how this correlates to the code when we have a validation for the scope before processing a request. Finally, now that I have my authorization server and I have scopes, I need to tell some way that only few applications can actually have access to scopes, specific scopes. So this is what I'm doing here with access policies. So let me create one, and the name I'll decide it to be Okta ICE API policy. Let me just have this name. And as a description, I'll come up with policy. Oops, I accidentally hit enter, but I can still change the description. Policy for accessing the promos accessing promos API via UI. And then I want this available just for few clients, right? Actually, most specifically just for the Promos UI. So imagine you can have several different applications. Imagine that you have a administrative application and you have the Promos UI one. So you can create a policy for each one. In one of the policies, you can say that the management app can actually create and delete promos. This UI, which is only for end users, can just actually read the promos. So okay, now that I have a good description, I have a client that's assigned to it, let me just create a rule. In the rule, I'll say that this rule will be read-only. And what I'm basically saying here is that the Promos UI will be available only to read promos and not doing anything more than that. Okay? So, and to use that, I have several different OAuth flows for requesting my promos. I'll just use the implicit for that in the authorization code. So these are the only ways the application can request tokens. Okay, these in OAuth are what we say grant types or flows, and you can learn more about this if you go oauth.com or sign up for our OAuth and OIDC course. Within the scopes, I say what the application is able to do, and what I will grant the application the rights to do are to grab information about the user using OpenID, email, and profile. These are the standard scopes provided with OAuth and OpenID Connect. And then, in addition to them, I'm adding promos, read, as you can see. And then let me go and create this rule. So now I have all my administrative side configured. So I have an authorization server with custom scopes, and from those custom scopes I have an access policy that says only the Promos UI can access the read-only promos. This gives me a lot of granularity, a lot of control over authorization, and because I'm not touching code over here, this is actually available for security administrators in case after you complete your app development. So you can develop your app apart, and you can have your administrative crew in workforce taking care of your app and who can access what in your app after everything is done. So going back to our presentation, I want to point something really nice about API-AM is that API-AM basically expands Okta configuration. If you have Okta already set up in your org, I'm pretty sure you might have MFA, some extra policies, several different applications registered with different users. Those users are already signed up to multi-factors. Maybe you have Okta Verify, maybe you have YubiKey and all that. And Okta API-AM is just an extension on top of that. So you correlate, if you have applications that are registered with OpenID Connect, you just correlate those same apps to the policies you have in API-AM. The users, because they are assigned to apps in Okta, the dashboard, right? They automatically, this kind of relationship is automatically transferred to the API-AM configuration. Because API-AM is only an extension to what Okta Single Sign-On already provides you, implementing it on top of Okta just to provide that extra API protection layer is a subset of what you would do in case you had to create the same thing in a different system. If you have another system for OAuth, you might be required to load all those users you had from Okta, set up their own security, have a different login and password, so on and so forth. So by implementing API-AM on top of SSO, this way I'm showing you, you can actually save time. So okay, now that we implemented the configuration, it comes the second part. What we will do in the next lab is modify our ICE promos code to do a OAuth 2.0 validation and to make sure the promos read scope is present before we process an answer to that /promos/premium call. Let's go and check this out. Back to my desktop. Now it's time to shift focus. So I'm minimizing here Okta, and now we're gonna work only with the REST API code. We're gonna modify that promos API code so it actually expects and validate an OAuth token before making the premium call. To do this, the first thing I'll do is actually finish my current work in here and jump into my source code, which is right here under server.js. Before I modify this, I'll just show you real quick the kind of data, the kind of code we have in here. We have some of those promos you could see from the REST API created over here, and we have few promos that are actually flagged as premium. We have several API calls over here in the code, but the most important one here is the promos/column filter, which basically says if you make a call to /promos/premium capital, it will return all the REST API, all the JSON for target equals premium. If I make a public, target equals public, target equals robot, or any other filter I can have. So this is the one we want to protect over here. We already have a few others here, like creating promos or deleting promos that are already protected, and I'm gonna tell you what's in there in about a few seconds. Now inside here, the first thing I want to do is to make sure this REST API I have knows who's the issuer for my call, who's actually generating the tokens, and where is the information I need to prove the token, that the token is real, is not tampered with. Remember that information, the issuer I copied from API AM? This is what I'm replacing over here under issuer. Alright? Good. The audience is where my application is running. Remember, there in the past, in API AM, I entered localhost column 5000 as the audience. This is the same value I put over here in my application. And this information will be used when I protect my token. Just make sure the token is supposed to be for my REST API. This code I'm working on, it's created with Node.js. And Node has a great library for working with OAuth, which is Passport.js. And this is what I'm using over here. And you can see that when I put my strategy to work, when I put my protection, it actually uses the issuer and the audience as configuration for protection. Now that I'm done with this, let's scroll down to that filter call. And in this filter call, I'm just uncommenting this line in interest of time, but I will tell you what's in here. Okay, so every time someone makes a call to localhost column 5000 /promos/ whatever, in my case /premium capital, before the call is processed in this function respond, I'm using Passport.js to make sure that I have an OAuth token. And this OAuth token, if I scroll up, remember this information I told you, must be issued by Okta, my Okta API AM. And the audience must match what I have over here. Only after that I have an OAuth token, and this token has a special scope named promos read. I can actually go process and read the premium promos. You see how everything makes sense, right? In API AM, I defined there will be a token, an access token that will be available for requesting the promos read, and the REST API, at any time there's a call to /promos, in my case /premium, it must validate that promos read is present and it's sent with the no-auth token before processing and answering with premium promos. Now that everything is fine over here, let me just save my file and run again my API. I'm back to ICE Resource Server where I have my application hosted. I just came up with npm start and we are back. And look at how interesting things are right now. If I make a call to public promos, the promos are still working. Remember the second call where I could get the premium promos? Now if I try and make the same call, I'll get a bad request. And if I open my source code over here, my debug and output, you will see that I made an invalid request that must specify an access token. In consequence, my request is not authorized. By the end of the day, this is what I have now. My application is fully protected with Okta. My REST API is fully protected with Okta. So something that I really like about Okta in API AM is that it's OAuth standard. Because it's OAuth standard, it can work with libraries you already know and you are familiar with. In our Node.js application, I used Passport.js. And as you remember, I just changed the authorization URL in the issuer to refer back to Okta. And then that promos read custom scope I created, which I expect in the in the access token, I check for it. If the request doesn't have it, the user is not authorized to make a promos premium call. Because Okta supports standard OAuth 2.0, I can integrate with standard OAuth libraries, and this saves me a lot of time, right? If I'm used to work with Passport.js or with other popular authentication and authorization frameworks or libraries, it's just a matter of setting with the right parameters for protecting it. And yes, with this we made it, right? So now hackers, they can no longer access my premium promos without having a token issued by Okta. There's just one detail we forgot to test and make sure that everything is alright. So you know what, let's just go to the API and see how everything is running. So here back to my environment. Oops, actually this is the right place. So I could check it out that the premium promos requires login right now. So let me just log in here as john.smith@octaice.com with my password. And I'm from inside here, after login, I have my profile. Let me go premium promos and let me try and make a call. And nothing happens. Let me turn on my debug and see what's happening. Okay, let me try again. And you know what, I can see already there's an error in here, but let me click clear and repeat this call. Oops, I get unauthorized. You see over here, I'm making a call that's to that same localhost colon 5000 /promo/premium. But the answer is telling me that I'm not authorized to make this call. Let's try and understand why. If I go and open my application, I can see that I have an invalid token. You see over here? This is happening for two reasons. Let me show you those. The first reason is that my access token, although it's generated, its SSO is provided by my Okta environment, it's not actually provided by the API-AM authorization server that actually has the rights to grant that promos read access token. The second thing is that when I open my access token here, and to do this, I'll show you how this information is displayed on JSONWebToken.io. Oops, a moment. You see that I don't have that scope promos read. So what happens is that my application is protected, my API actually is protected, but the IceSpa app doesn't know yet how to make a call with the proper scope and authorization to my Promos API. Hence, this is not working yet. So just the API is protected. So what we need to do right now is to work on the UI and update it so it uses the Promos read scope. And not only this, but also it talks to the API-AM server to issue the tokens we need. Within the next lab, we're gonna do that. See you soon. Here we are back to my environment. Just to recap, the API is protected. The /promo/premium requires a token with promos read, and this token must be issued by our authorization server Promos API. The only thing is that our UI is not aware of this yet, so we need to modify the code in Promos UI to ask for tokens and scopes in our new issuer, the API Access Management, and ask for the Promos read scope in order to read the premium promos. Let's change the code in the Promos UI to make this work. So inside my Promos UI, I'm opening that auth index.js file where I have all my OAuth authorization request and call set up. And inside here, the first thing I will do is to update this authorization server. So instead of going with the default Okta.org URL, actually I'll go with my issuer from API-AM. You see there's a new URL over here right now. And the second thing I'm gonna do is update my authorization server URL over here just to remove this /OAuth2. So I have /v1/authorize straight. This is the way API-AM, this is the endpoint in API-AM for making authorized calls with the scope, request for the scopes and tokens. Third thing I would do is update the scopes. And now that I need the promos read, I'm gonna add this over here to complement the other ones I'm already using to get information about the user. After I'm done with this, let me just control save what I have, and now my UI is ready to go. To make sure everything is fine, let's check the results. I'll launch an incognito window to make it simple and easier to validate, and I'll go to my UI, localhost 8080. And inside here, I can still for sure make calls for public promos, and when I go premium, I need to log in. Let me log in as John Smith, ice.com with his password. And now the first thing I want to show you is that the SSO now is provided by API Access Management. And within my access token, I have more information that I used to have before. If I go back to JSONWebToken.io and I paste that information, me clean up here. You see something new and different. Now you see that promos read is a scope and is included in the access token, and the access token is issued by API Access Management. So everything starts to link together. And with this access token, if I make a call to premium promos, actually I get the premium promos. When I go here and I launch my Chrome Developer Tools, I want to show you something. When I make this call, the call goes with the access token as header. You see here? We're gonna talk about this in a second. But this is basically the information that the Promos API needs to make token validation and make sure you are authorized to make this premium call and actually have access to the premium promotions. Now, if I try to make that same call outside here, you see that I still cannot have access to the premium promos. Only that application that has the proper access token can do that. So back to our presentation. I want to show you something really nice about API Access Management. API Access Management works with the libraries that you already use with Okta. So for example, if you use Okta Auth.js like I do in my example, I just had to modify my authorization server URL and issuer to work with API AM, and I included on top of my OpenID scopes the OAuth scope promos read that I used to access my premium promos. Okta API AM works not only with Auth.js, but also, for example, with the signing widget from Okta. Because you are using libraries you're already familiar with just to tap into OAuth in OpenID Connect and to get your tokens, you don't need to spend time with other tasks, which saves you for sure a lot of time by the end of the day. So by just modifying some attributes and the way it works, you already have the full result, a secure session. So yeah, as you could see from the results, the only way to get the access token to our premium promos is through our app, the Promos UI. Remember in that policy we had in API AM, the only app able to request premium promos read was this Promos UI app. This way you have actually a security end-to-end tied not only to the user but actually to the app. And I put this slide just to show you how the authorization is passed from the Promos UI to the Promos API. Remember when I showed you that authorization, bearer, space, in a bunch of characters, which was the access token? The Promos UI have this extra function that implement the red header authorization with that information. This is basically the way the Promos UI tells the Promos API, hey, I'm making this call, but I'm sending you the access token. The access token works almost like a cookie would work in your browser, but this is being used in an API, in an app to API call. This is actually the standard way we implement OAuth when we make API calls. This is the OAuth better token call. Remember we used Passport.js. Passport.js is OAuth compliant. It knows the access token would come up this way and use the passport.authenticate function to get this token from the authorization bearer and to make all the OAuth validations that are expected, including validating if you have the proper scope to make the premium promos call. So yes, now it's true, you finally made it. So we integrated the UI with the API. We have security here provided by Okta API Access Management. And hackers are no longer able to access the premium promos. The only app that's able to do so is the promo UI. And the promo UI can make that after the users log into application using their Okta credentials. So to recap, you learned what a modern application is and what its security requirements. You learned how APIs can be exploited and how to protect them with Okta API Access Management. And finally, we discussed how a modern application can benefit from the security API provided by Okta. To learn more about OAuth and OpenID Connect from scratch and to implement single sign-on, authorization, and social authentication, sign up for our new course, Single Sign-On in API Access Management with OpenID Connect and OAuth. The Help Center is another great resource to stay current on the latest Okta technologies. And if you are already an expert, take the certification challenge we presented at Oktane. And stay tuned for the launch of the Developer XM in 2018.